why is computing in steps, why does that not work when it comes to doing something like self-driving? Um, for one thing, the reaction time. No matter how parallel you make the computation, um, you still have to be doing one line of code at a time, one frame of video at a time, it's always one little bit of information at a time, and so um, there's always going to be this big delay from the time that you're capturing an image, processing it, making a decision, that no matter how fast you make the processor, no matter what, you're not going to be able to get over this hurdle to get this reaction time. And I don't know how to explain all this. So like the one thing that works stepwise, like everything in computing does, even right down to the camera. The camera itself only scans one line at a time in the frame. You have to wait for it to scan all of those lines and capture the image. And what's so interesting about video is that we've never had analog video. It's always been, I'm not sure if you would call it digital, but the signal has always been stepped in this way. So it's like the old analog TV signals and their cameras, they still worked in the same way of scan lines and fields and whatnot. Just the different terminology they use for the frames. But even though they're broadcasting it over an analog signal, like your TV still has to wait or sort of buffer the information that's coming in from the video. It doesn't get it in real time. Even though the signal is analog, it's not real time. Like with an audio signal that's transmitted over analog, the signal is transmitted in real time. Like I sing the note A 440 hertz, then every vibration that I make that gets transmitted, it ends up being like 1-to-1. But if you have a video of me doing that, it's not because of the way the data gets broken down. And this is so fascinating. So the interesting thing about audio is that audio processing is real-time computation. It's not done in steps. So if you have an audio signal and it goes into your mixing board and it goes through some effects and then comes out of the speakers, there's no delay. The only delay is the time it takes electricity to flow, which is at the speed of light. And so the only delay is like the length of your circuit in the speed of light, and it's not you're not waiting for a computation to happen. You're not waiting for the data to be broken up into chunks and being and be manipulated in that way. It just all happens all at once. And with video, we've never had that. Video has always been broken up in chunks. Oh, okay, now with this video problem, there are examples of technology that sort of tackle this. So one example is smooth scrolling. It's something that all the Apple devices have. And what this does is it takes advantage of the way that the screen refreshes to animate, to draw the animation for when you're scrolling something on the screen. And so instead of rendering the frames one at a time for the animation and then sending them to the graphics card one at a time, you render it as if to take advantage of the screen refreshing, because it refreshes one line at a time. And so by doing it, by sort of timing the pixels, you can create these effects where the screen is able to scroll very smoothly because you're updating it in the way the screen should be updated, not updating it in the way that we think about video in terms of these frames. Now, what's interesting is, why haven't we been doing this with video in the first place? So this is something we could already be doing with video. So when you think about it, when video gets captured, it does the same thing. The sensor scans one pixel at a time in each row and records the value in it, and then it goes in the next row and scans this. And so in time, the actual frame isn't capturing a single moment in time; it's capturing a whole progression of time. And so if you take if you know the exact refresh rate that the camera was at when it recorded the video, and you know the exact way that your screen refreshes and draws the lines, then you should be able to sync these two things up so that the video appears like it's 1,000,000 frames per second. And this would be an example of analog video. And why is it 1,000,000 frames per second? Because each pixel happens that it is capturing a different moment in time. and so therefore each pixel can display at a different moment in time when it's on the screen as well. Um, it's just absolutely fascinating. Now, why is this important? Because the techniques for doing this is what is sort of the starting place for creating a real time AI, and you need to a real time AI to sort of compute things quickly. You need for tasks like driving a car, whereas a general purpose stepwise AI that just computes things in steps you can use for sort of any calculation you need to do. Um, but to do these fast, quick thinking um, decisions, you need to be able to analyze these signals in real time, and we know how to do this from um, manipulating audio signals. And so but our technology for manipulating audio signals is, in the grand scheme of things, quite primitive in terms of how like our brains are able to manipulate signals and process them into consciousness and intelligence. So, we have to treat your video signal like an audio signal. And so instead of treating it as thinking about it as a bunch of frames, you have to think about it as each pixel being an audio signal that's continuous, that um, you couldn't have a distinct point in time where you say it's either this color or this color. It just represents this color, and then it changes as through time, just as an audio signal does when notes change and whatnot. Um, and so, um, it's cool. You can kind of do like a software prototype of this, where I mentioned with the pixel timing, where you analyze the video signal differently and sync it up so that the way the camera is scanned lines up with how the screen is scanned. Um, that gives you like a prototype way to do this digitally, but in an analog, like physical way, um, which is kind of interesting about developing the AIs, that you can do a lot of the stuff in computer, and then you have to make like an analog, real world version of it to actually make it run fast. Um, but so the analog version of the real world version of the video, you have to make a camera that, instead of just having um, like the way the camera sensors and TV sensors are built, they only have lines coming off the rows and columns, and so you need to have lines coming off of every single pixel so that you can get a signal off of every single one, um, and then be able to take those like in a 1080p signal. It's 1920 by 1080 pixels, which is roughly a million different signals you have, and then you have to, on the monitor side of things as well, have a way to plug those a million um, different pixels in, and then in doing that, you have uh, all of these signal processing challenges of amplification and noise filtering, um, to be able to set up a camera system like this, and then uh, from there you have a new way of thinking about video in terms of, well, now what does recording a video look like? What does editing video look like in this format? What does Um, if I want to scale, zoom in on a video, but it's in this analog format, we have we have to have a different way to do that, especially in the hardware sense, right? Like just like in the hardware, we have like in the audio world, you have like a compressor, or you have a reverb or whatever, and so in the hardware world for processing video, you would need things like um, um, uh, like scaling for zooming in, um, object detection, and whatever else. But to work on this other format of video. And so why does this help with developing a general AI that can do things like drive a car? Is because we need this knowledge about how to um, process signals in this way, and to process high volumes of them. Um, um, do transformations on analog data. So like we can do it with sound, we can do transformations on analog sound, but that's just like one little, it's just one pixel, right? And so be able to figure out the different transformations, just basic computational transformations that you can make on a video stream represented that way. Um, and hmm.